Hello everybody, welcome to the fifth installment in this professional development on mastering our basic math facts, at least the fifth segment in terms of multiplication. So today we are moving from where we began with looking at times 2 facts, our doubles and our pairs. Then we moved on to our times 10 facts. From there we went to times 5, and now we move into our times 1 facts. So in this session, we'll look at why this order of the facts. We'll look at where we are in the process, look at some skills and things you can use, tools that you can use in the classroom, and wrap up by looking at how division works, and also a little bit more time on how to progress monitor as we're going through our multiplication facts. So you might be wondering, well, again, why didn't we just do zeros and ones early on? Well, that certainly seems to initially make sense. Like, why we should probably begin with 0 and 1. Those are quote-unquote easy. The struggle that we run into with kids, though, is they can remember that 1 times anything is that number. What they lack, though, is this knowledge that what we're talking about is groups of 1 or one group of something. So by beginning with groups of 2, groups of 5, and groups of 10, what we do is we begin to build that concept that what multiplication and division are is efficient ways to think about grouping. And so if we start with zeros and ones, kids get an idea that I'm just supposed to remember these multiplication facts, and they don't necessarily grasp onto the idea of why and what those are representing. So that's the biggest reason we're going to go to ones after 2s, 10s, and 5s. And it's also that a group of 1 or one group of something is kind of tricky to visualize, because when we think about one group of 7, well, why don't we just say 7? Because normally that's what we would do. So it's a little bit more abstract to think about groups of 1 or one group of something. So what we're really shooting to do here is to build the concept. Let me flip over to our document camera just for a quick second to remember these are our processes, this is our process of going from our foundational facts and then into how we build upon that foundation. So you'll see we are now at our 4th foundational fact, right? And so we'll have one more of these sessions, and then we'll move on to the rest of the strategies which require students to understand their 2s, 10s, 5s, 1s, and 0s in order to be really efficient with that. So as we move through this, let's think about our big picture piece. And again, this is a picture from the text. The gray areas are the facts that we have already addressed. So we can start to see our multiplication chart fill in. We start to see where our gaps are. And the bold numbers are our ones facts, which we'd be working on if we were working with kids in this. We'd be working on now. So we start to see our little pockets of areas begin to shrink. And so we'll continue to look at this chart as we move through. And what I ask you to think about is, so who is this information useful to? Obviously, as teachers, it's nice to know kind of where we are in the process. But in terms of especially of our struggling kids, and might this make it a little bit easier for some of them to realize that they're not learning the whole chart at once. They're not learning a whole bunch of new facts. We're really just learning these certain ones right now. So you already know the other ones. Just plugging in that this isn't maybe as overwhelming as a student might initially think. For our high achieving kids, this might be a little bit more to challenge them to think about what do they already have mastered. Maybe they're keeping track of their own chart. And where they're already fluent and where they're growing. So 2 simple big ideas, or 2 basic big ideas, maybe not simple, that when multiplying by 1, the product is always the same as the other factor. So if we're multiplying 1 times something, whatever that other factor is going to be our solution, and we call that the identity property of multiplication. And obviously the commutative property comes into play here too, that the order of the factors does not change the product. It changes what it represents, but it doesn't change the product itself. So just some questions that come from our text. These might, again, be good things to have posted around the room, to revisit maybe at the end of a fact review time, and just to have around for general discussion. So just the simple ideas of what does it mean to multiply by 1? What's it mean to have one set? Why is that product always the same? What patterns are we seeing? Does the order affect the answer? And what is the connection between the multiplication equation and the division equation? How do those two things play together, and how can I use one to answer the other? So our literature link for this section is one that probably took a little bit more thinking when you think about, well, what text could we use that really focuses or that can bring focus to groups of one. And so the text that the authors chose here is One Tiny Turtle. What you might want to do, there are so many connections within turtles and just personal interest for a lot of kids, that this might be a good place to bring in the science piece or even the social studies piece, because as you'll see in the text, you're going to deal with the issues of conservation and protection of wildlife. So this may be a good text to use, not simply to do multiplying by one, but to give kids a chance to explore some things that we might be talking about in social studies or science as well. So if you're going to do that, then we encourage you to use the KWL chart, and I'm sure you're all familiar with KWL. I like to think that the K, instead of what I know, is sometimes with kids, it's what I think I know, and then the W, what I want to know or what I want to learn, and things I've learned. So if you're using this text as more than just the mathematics, then you may want to do something like the KWL that you can revisit after the text. So let's jump into the story itself. So let me flip over to our document camera and get us zoomed out appropriately. So this text is by Nicola Davies. It's illustrated by Jane Chapman. There is an informational piece at the beginning of the text about sea turtles themselves, which we would certainly want to read if we were working with kids, but for sake of our time here, we will jump forward. And so our story begins like this. One tiny turtle. Far, far out to sea, land is only a memory. An empty sky touches the water. Just beneath the surface is a tangle of weed and driftwood where tiny creatures cling. And this is the nursery of a sea turtle. Passing in a boat, you might not notice. Not much bigger than a bottle top, she hides in the green shadows. She's a baby, so her shell is soft as old leather. Just a little fish bite could rip it open. But the turtle is safe in her world of weed and snaps her beak on tiny crabs and shrimps. Turtles have shells that cover their back and shells that cover their stomachs. Their shells are made from bony plates that get bigger and harder as the turtle grows. The turtle swims around, flapping her long front flippers like wings. She is flying underwater. She pokes her pinprick nostrils through the silver surface to take a quick breath. So fast! Blink and you'll miss it. Then she's gone, diving down into her secret life again. Fish breathe underwater, but turtles are reptiles and need to come up to the surface for air. They do this every 4 to 5 minutes when they are active. When they're asleep, they can stay underwater for hours. For 3 or 4 years, maybe even more, the turtle rides out the storms and floats through the hot calms. Steadily she outgrows her nursery. Nobody sees her leave, but when you look for her, she has vanished all the same. A year or two later, she turns up close to land, bigger than a dinner plate now. She's not a fish snack anymore. Her shell is hard as armor. Her head is tough as a helmet. She's grown into her name, Loggerhead. She has come to eat crabs. Millions swim up from deep water to breed in the shallows. Their shells crack as easily as hen's eggs in her heavy jaws. But in a week the feast is over, and Loggerhead disappears again. Loggerhead wanders far and wide in search of food. In summer to cool seaweed jungles where she finds juicy clams and shoals of shrimps. And in winter to turquoise lagoons, warm as a bath, where she can munch among the corals. Loggerhead may travel thousands of miles, but she leaves no trace or track for you to follow. Only good luck will catch you a glimpse of her. For 30 years you might not find her, and then one summer night she arrives on the beach where she was born. She's found her way back here, sensing north and south like a compass needle, feeling the current and the warmth of the waves. She remembers the taste of the water here and the sound of the surf. Male turtles wait just off the nesting beaches. They mate with the females, and then the females come ashore to lay their eggs. Loggerhead has grown into her wandering years. She's big as a barrel now. Floating in the sea she weighs nothing. But on land she's heavier than a man, so every flipper step is a struggle, and her eyes stream with salty tears, which help keep them free of the sand. Coming ashore is very risky for sea turtles. They can easily overheat and die, so they only nest at night or in cool weather. Then they get back to the sea as soon as possible. Loggerhead makes her nest where the sea won't reach. Scooping carefully with her hind flippers, she makes a deep hole, a steep, deep hole. Inside she lays her eggs, like 100 squidgy ping-pong balls. Afterward she covers them with sand to hide the nest from hungry mouths. Then Loggerhead is gone again, back to her secret life. Left behind under the sand, her eggs stay deep and safe. Baby turtles grow inside. Females stay close to their nesting beach for several months, and in that time they usually make at least 4 nests, and sometimes as many as 10. And before the summer's over, they wriggle from their shells. Turtle eggs in warm sand can be ready to hatch in 6 weeks. If the sand is cool, they can take 3 weeks longer. Above them on the beach, 100 eyes watch, on the lookout for a meal, so the hatchlings wait until night. Then they burst through the sand and skitter towards the sea. The horizon where the sea meets the sky tells baby turtles which way to turn to get to the water. But street lights and buildings next to the beach can confuse them and make them go the wrong way. In the dark, claws and beaks and grabbing paws miss only one young turtle. One day she'll remember this beach, and she will come back. But now she dives under the waves and she swims, swims and swims, out into the arms of the ocean. Far, far out to sea, land becomes a memory, waiting to wake in the head of that little turtle. And so the process would begin again. So that is One Tiny Turtle by Nicola Davies. Let's see if we can make some of those connections back to our mathematics. Again, if you want to make the science connections, those are pretty apparent here in the literature, in the KWL chart. You can also, like I say, make a lot of social studies connections, but we're going to focus in on the mathematics. So just some reminders as we're reading through, especially on a first read, we always want to make sure that we're focusing in with as few interruptions as we can, focusing on the literature, building a concept of what's going on, and then we can go back into the text and pull out the math through a reread and through some more critical reading. So after reading, so what are we going to do with kids here to help them make the connection between this text and the multiplication by 1 or the math facts that we want them to think about? Well, we're going to give each pair a little group of a bag of counters, and we're going to make those like their turtle eggs, and a small paper plate. So you can picture our kids with a little baggie of Unifix cubes or a little baggie of color tiles and a small paper plate. And they're going to select some of the counters from that bag. So the bag, it doesn't matter how many are necessarily in there, but rather that there are just a bunch in there. So they're going to pull out some, they're going to put them into their turtle nest, and they're going to count their eggs. They're going to draw the picture of their nest, and they're going to record that on their sheet. And then the teams are going to write out their multiplication sentence. So we have a worksheet again that you could use or not use. So they're going to draw out their nest, right? So they're going to get their nest, and they're going to put their eggs in their nest. So here we go. Let's just to make this simple, we'll say that this group chose 3 eggs, right? So they're going to draw that in there. And then we're going to write a multiplication equation. So we have one nest, right, times 3 eggs tells me that I have 3 total eggs in this case. So again, the 1 is the number of the nests, the 3 is how many eggs are in there, and then the total number. So then they're going to pick another bag, and again, if you just you could do this with by counting out the eggs and putting them in the bag. As a teacher, I think if I was doing this in a half class or a whole class, I would just give them and ask them to pick out a different amount. So they're going to choose and do the same process again. So we're going to have another one. We're going to put some eggs in there and then write out the multiplication sentence that goes along with that. So it's going to be one group times however many eggs there are, and that's going to give me the total. Whoa, I guess I'm zooming in. Sorry about that. That's going to give me the total number of eggs in there. And then we'll do that a third time. So again, we're trying to build we're trying to build the connection back to the text so that we can keep reaching back to this when a student is struggling, but we're also just giving them a little bit of repeated practice here. So after we've done the baggies, now we're going to ask them some things, just some probing questions, like what did we notice in the three examples that they created? What's the same? What's different? And then for our kids that are ready, can we extend this thinking? What if there are 19 eggs in a nest? What about 25? What about 100? And then would you be able to tell how many eggs were in one nest? How would you represent that with a multiplication equation? How would we write that out? You could go back to the KWL charts again if you're making these connections back to social studies and science, but just thinking about the math here, what we want, or what we're hoping that kids are gradually starting to do, and this would be the very initial entry into this, is that they're starting to realize, oh, if I have one group of something, then that same product, or the solution to that, is going to be the same as that factor. So one group of 7 is always going to give me 7. One group of 10 is always going to give me 10. And so we're trying to build that idea. Another activity to try to build this, and again just extend the thinking a little bit longer, is to create 10 bags of color tiles, putting 1 green, 2 red, and 5 in there. So you'll see the 1, 2, and 5, and you may say, you'll probably quickly recognize what we're trying to do is give practice back to our 2s and 5 facts, and now we're introducing in the 1 as well. So going back to just make some connections to previous learning, right? How many yellow tiles would be in 1 bag? How many yellow tiles are in 3 and 8 and 12? How many red tiles are in 6 bags? How many red tiles just are in 1 bag? How many red tiles? And then how do we write those out as multiplication sentences? So thinking aloud is going to be needed, especially for kids that are struggling. We're going to want to give different amounts of time for different groups of kids, especially if we're doing this whole class. And then we can move into, well, what about the green tiles? Well, we're building to this concept that if I have 4 bags and there's 1 tile in each bag, well, that would be 4 groups of 1 gives me 4. So this is one of those places we'll talk later about how it's a little bit awkward to talk about groups of 1 because it's just 1. So, but this is one of those places where if I had 4 bags, well, 4 bags in this case is going to give me what? 20 yellow tiles, 8 red tiles, but 4 green tiles, because it's 4 times 5, 4 times 2, and 4 times 1. So sometimes, especially as we get into ratios and things like that, sometimes the group size is 1. And so we need to make sure we've got that thought in a child's brain as well. I like one of the ideas in the text about student rule books. This may be a good place as kids start to make their own conjecture, their own thoughts about if I have a group of 1, or if I have 1 group of anything. My rule for multiplying by 1 is, we know we can give kids all the rules in the world, but until they make it their own, they're really not going to hold on to it for long. They might like our rule and they might keep it, but we'd like to see them not create their own rules, but create rules that make sense to them. So I like the idea of kids creating their own multiplication books, and at this point they would have rules for my rule for 2s, my rule for 5, my rule for 10, my rule for 1. And we might not want to start that at the very beginning of a multiplication exploration, like back when we were doing 2s. because they're still thinking about and working through their facts. So this may be a good place now that we're into the fourth fact and we're really thinking about how am I going to remember these long term? So my rule book kind of thing for multiplication. One of the, as we think about all kids and kids that are struggling, and again, kids that are struggling may eventually be the ones that outperform, but it might just take them a little bit longer initially. So it's one of the common misconceptions or the common struggles for kids has to do with they're so ingrained with addition by this point that when they start to multiply by one, it's hard to make that mental leap from, well, when I add one to anything, I just get the next counting number. So they've done that so many times that now when we start saying I multiply by one, well, that's a different thought process. So giving kids a lot of examples, a lot of chances to act it out physically with manipulatives, finding scenarios, writing story problems, doing that again and again and again is one way to leap through that hurdle. Are kids going to make mistakes? Sure. But we can limit those mistakes by giving lots and lots of focused practice. And that focused practice is not going to be found most likely by just writing out the facts, but rather by acting them out, by drawing them, by creating scenarios, and then pairing that with the abstract writing of it. One of the clarifications, again, just that multiplying by one facts are easier to memorize a lot of times, but they make it gets confusing because we tend to go too quickly through the multiplying by one facts, and kids never really build that concept. So what's one way I could do this again and again with kids without taking a lot of teaching time? Well, one of the digital downloads here allows kids to pick which fact are they going to do, to create a scenario and then draw it out. This could be one of those morning work pieces or afternoon pieces before lunch, after lunch, where kids get a chance to choose their own problem. And these, again, these are all in Word documents in the digital download, so we could easily change the facts to be some of the previously learned facts. It makes for some great bulletin board work as well. Acting out the facts, going back to our literature piece, again, always good. We're using the text to build a concept in the mind, to build a context, to be able to reach back into. So they built equations for a number of eggs in one nest. So now we're going to, again, explore, well, what did you learn about the product when there is just one group of something? But what if there are many groups with just one in each group? So we mentioned this is not a concept we use very much, although we saw it there in the color tile activity. By acting out like, okay, so I'm going to give one pencil to 7 different students. Well, what is that in a multiplication sentence? Well, that's 7 groups of 1 gives me 7. Oh, there's this piece of, sometimes I do groups of 1. If everybody gets 1 of something, that's a group of 1. So maybe it's more common than we think. We just don't think of it in multiplication sense. So we definitely want to get that into writing that out. And then that gets to move us towards building our automaticity. And so again, we remember that automaticity is building this automatic response, this idea that I know this so well, it's so connected, it's not memorized, but it's so connected in my brain to so many different schema that I can just grab it whenever I need it. So once we have the concept, we can move on to activities and stations. The danger is if we jump to activities and stations before we've had a chance to verbalize and draw pictures, the kids are going to make errors, and they're going to have misunderstandings in ways that we would rather they don't as teachers. So targeted practice is certainly good. Selecting just those times 1 facts. Again, this is out of the digital downloads. After repeated practice, we can certainly incorporate previous facts. We'll look at some of those in a minute. Math Towers is one of the activities shared in the text, and this one's, again, relatively simple, but a good chance to just keep practicing the multiplication by 1 facts in a way that's a little bit more engaging than just doing flashcards or doing things back and forth between pairs. So kids are going to spin a spinner, looks like this, right? So they're going to spin the spinner, they multiply whatever they get by 1, and they put a marker on that floor. So they're not, if they get 9, they don't just go up to 9. They're just putting a marker on the 9. So they might do So if I spin a 9, I get to put it there. My partner spins, he gets an 8, he puts it there. I spin and I get a 7. My partner spins and gets a 6. I spin and get a 9 again. Well, now I've used up all my 9s. And my goal is to cover all the floors. Now you could decide, are you covering one set of floors or do you have to cover them both? So again, it's just repeated practice, and you can see this is going to take, even if I just got lucky and got 10 straight in a row, it would still take me 10 times practicing my multiplication facts. So, and with a partner, we could go back and forth on that. So we're trying to cover all our floors. Math checkers, I love this one. It may take some teaching. Some kids may not be all that familiar with checkers. It plays just like regular checkers, except in order to move to a new spot, I have to be able to answer that fact. So if I can't answer the fact, then I can't move to that spot. This one is also in word form, which is beautiful. So this is easy to adapt. If we were just looking at math fact practice, you could put those 2s, those 5s, those 10s, and the 1s in a table like this, or in a math checkers. And again, just more engaging than just doing flashcards. As we work through, we know that as we're moving forward with our math facts, we've got to keep track of progress. And so we're going to look at a few tools to do that. You have both just the single facts check sheets in the digital download, as well as mixed review, as well as a monitoring tool. So you can certainly use the sheets to do this as a larger group, with the remembering that it's okay if Michael's over here working on my 5 sheet and my person beside me is working on their 1 sheet, that's perfectly fine. Again, we're going to work through them as they make sense to me. I'm going to practice the facts that I am ready for, not necessarily the facts that everyone else in the class is ready for. So whole group, we might be doing some common exploration of multiplying by 1, but perhaps I'm the student who isn't ready for that in terms of individual fact practice yet. So I can keep working on the ones where I am. So let's talk about what's one way to do that in terms of formative assessment or in terms of benchmarking with kids. You would want to start with the simpler facts, right? As a child misses a fact, then you set that card aside. So I've asked these 3, I've got my pile that I want to ask this student based on where they are. I'm going through them with the student. Oh, missed this one, I'm going to set it over. Do a couple more, misses another one. Once they've missed 5 facts, and I've set those 5 off to the side, now I'm going to talk with that student and say, okay, these are the 5 facts I want you to practice. Let's do some shared goal setting. These are great places to use the student's agenda. Now let's do some shared goal setting, and let's decide when we're going to get back together, and let's then sit down. Maybe it's a week from now, maybe it's 2 weeks from now, depending on time and availability. One of those things that you might not have to do all that often with your kids that are flying through their facts and just understand them, but it may be one that you have to do more often with some other students. So you have your mixed review sheets, you have your individual fact, your mixed review sheets, and then for really tracking progress, we've got here our what does it look like in terms of doing multiplication and division together. When you're getting into students who are really struggling, and you might want to explore the idea of doing an automaticity interview. This is a good way to keep some data on a student. Not necessarily a special needs, but it may just be a slow learning student. It may be a student who just needs a little extra practice, and you want to have some good data to show week by week or every 2 weeks where the student is going. So this math fact automaticity interview is in the digital downloads as well. So there are some directions here in terms of how to do the interview. So we're going to pick 10 fact cards. Again, these will be based on the goals that we've set with the student. We're going to randomly present it. If the kid knows it in a certain amount of time, we're going to give them an automatic response. If they know it if it takes them a little bit of a strategy, then we're going to mark that. And if they don't know it, then we're going to mark it as unknown. And again, this is going to be 10 problems. So this is going to take, a minute, 2 minutes with a student. Something I can do with 5 or 6 kids early in the morning, in the afternoon. As a teacher, it's difficult to do these kind of interviews with all students. If that's beneficial to you, that's great. Great way to track progress, but it's probably definitely needed for our most struggling students. And ultimately, as we get towards the end here, we connect back to division, right? And we want to go back into that context that kids have with our tiny turtles, right? So we think about, what was that original multiplication sentence look like? Well, that was, if I have 7 nests and there's 1 egg in each nest, then that gives me 7 total eggs. Well, what happens if we flip it around, right? So a scientist found 7 eggs in 7 nests. Each nest had the same amount of eggs, and so how many eggs were in each nest? Well, if we're going to draw that out, again, we want to start manipulative concretely if we can. We're going to put our 7 circles. We're going to put 1 egg in each nest for the 7 eggs. We're going to represent that way, and then how do we write that as a division sentence? Well, that's 7 eggs in 7 nests, or 7 nests with 7 eggs gives me 1 nest in each egg. Right, so that's one way to do the division, right? And then we also know there would be 7 divided by 1 gives me 7 as well, as another scenario. We want kids to share those out. We want kids to work in partners, to work with manipulatives, to draw pictures and equations in the same way that we built the multiplication concept. We want to pair that with building the division concept. We're looking at what changes in each division equation. Where does that 1 fall? Where does the larger values, like in that case the 7 divided by 7, where do those 7s fall? What do you notice about the quotient in each problem? And do you think that every time we divide a number by itself we would get 1? Depending on the level of kids you're looking at, what happens when we have a half divided by a half? That really gets into another concept of, well, I've got to picture that. How many halves are in a half? So when kids own the knowledge, then they're able to explain it, they're able to draw it. One way to just explore that, right, is to look at how they are alike and how they are different. So this is also in the digital downloads, right, where we're looking at in the A scenarios and the B scenarios, multiplication versus division. What's it look like as a multiplication sentence? What's it look like as a division sentence? That brings us to the end of the multiplication by 1 section. I will say this every single time, so I hope that doesn't get redundant, but we want this professional development to be meaningful for you. So depending on the kids you're working with and where you are in the school year, that's going to mean different things. However, the one thing we ask after each of these is, please share the resources that you have, the ones that you use through our Edmodo group. We'll be moving next towards next session into multiplication by 0, and that's our final foundational fact. And after that section, we'll have a little bit of an assignment for you to do to kind of check in and see where we are. And then we will be moving on to the rest of our facts here. And so we thank you for your time here today. I thank you for your time here today. And if you have questions, feel free to contact me, Michael Elder, and I'll be glad to chat with you anytime.